Hey guys, today we have another battery from WattCycle. This is a 12 volt 314 amp hour lithium iron phosphate battery. There are a few different versions. This is the most basic, no Bluetooth, no heater. This video was not sponsored. I went out and bought this myself just to make this video. Let's do a bit of testing and then we'll tear it apart and see what's inside. This battery measures 14 inches in width, 10 inches in height, and 7.5 inches in depth. We have our typical carry handles on the side here, but as with any of these heavy batteries, I strongly recommend supporting it from the bottom. The left side of the battery features both the positive and negative terminals, and these are standard M8 bolts. This battery is rated for 200 amps continuous charge and discharge. You can connect up to 4 in series for a 51.2 volt system. It's rated for 6,000 cycles at an 80% depth of discharge, and at just 57 pounds, it is significantly easier to move around compared to that 628 amp hour battery we just reviewed a few weeks ago. I ran a capacity test using my American Reliance electronic load at 60 amps or a 0.19 C rate. The measured capacity was 322 amp hours or 2.5% higher than advertised. Taking a look inside the battery, we have our BMS right on top here. This is our main positive terminal and our main negative terminal. Coming off the negative, we have 3 6-gauge silicone insulated conductors, and the positive was comprised of 4 8-gauge silicone insulated conductors. I removed those to get this lid pushed back here. There are 4 cells down in there as we expected. It is a 12.8 volt battery. One thing that stands out very differently about this battery is there's actually a steel frame around this battery inside the plastic case. The connection points to the cell are aluminum bus bars. They are laser welded in place. Laser welds look very clean and nicely done. There's a nice thick stud there on top, and they used a serrated flange nut to hold down those lugs. Our balance leads are ring terminals. Looks like they are crimped on, and there is a screw holding them into the bus bar. This is the perfect way to connect balance leads in my opinion. We have nice thick aluminum bus bars for the series connections. We have an expansion hump in the middle there as well, and again the balance lead is terminated on a ring terminal and a screw. The balance leads coming off the BMS are fairly neatly done. There's not a spaghetti nest of wires like we sometimes see. They do appear to be trimmed to the proper length. This one is kind of resting against the BMS. I prefer not to see that. The BMS is held down to the steel frame that goes around the batteries here with 4 screws. With the BMS out of the way there, we can see the tops of the cells. There does appear to be a separator between all of the cells here. The center has a thicker epoxy board type separator. There is a separator between the left and the right pair, but it is a different separator, which is interesting. I did locate the temperature sensor. It is down under the bundle of negative conductors where I suspected it was. With that top bracket removed, we're now able to see the QR codes on the cells. It is not one that I recognize. It does appear to be an original QR code. It's not like a grade B or anything from what I can tell. Ooh. So that metal frame is actually separate from the battery pack. So we see our steel plates here on the left and the right, and you can see some steel straps. It looks like there's 3 of them here. Taking a look at the actual battery pack here, we do have some insulative, I don't know what this is, just a thin piece of plastic on both sides. These cells are heavy. I'm used to dealing with smaller cells and there's just like a lot of mass to them. The cells appear very clean. They are very straight. There's no bloating, no dents or anything like that, any sort of damage. I do believe these to be Rept Butero cells based on a quick Google of the QR code on top there. A quick look at the BMS doesn't yield anything of particular interest. It's a fairly standard basic BMS. There are no apparent brand names, however there is a model number in the lower left, 60544S version 1.3. There is a thermal switch here near the FETs. It's rated for 90 degrees Celsius, and that's going to be for your over temperature protection. Otherwise, it is a fairly basic BMS, but it does get the job done nicely. The battery is put back together and we're ready to test the low temperature charge protection. So I have a bench power supply here charging at 2.78 amps. It is going through the BMS and I have the temperature sensor pulled off. As per usual, I'm going to spray the temperature sensor with some of this computer duster, which should drop it well below freezing and cause the charging to stop. 3 seconds, it was about 3.5 seconds or so and it shut off. So let's go ahead and warm the sensor back up. 4 seconds, about 4 seconds and it turned back on. Let's test it once more. 1, 2, 3. 3 seconds and it shut off again. So this battery does have functional low temperature charge protection. I have one more test to run here. This battery is rated for a maximum continuous discharge of 200 amps. So let's throw a 200 amp load on it and see what happens. I have the battery connected to a Sun Gold Power 4000 watt split phase low frequency inverter. Going to plug in a couple of loads that should put this right around 200 amps and try to maintain it around 200 amps for the duration of this test. The test just shut down due to the low voltage disconnect of the inverter. You can see we pulled 313 amp hours. And what we're going to do here is really quick. So the top of the BMS is sitting at 144 degrees Fahrenheit. Oh, there's 147 there. What is that? 145 on the right. No issue with that test either. This battery is performing great. It handled the full current. It averaged around 195 amps or so for the full duration of the test without issue. This is another fantastic battery from WattCycle, and I see why it's one of their best-selling models. They're spot on with the pricing as well. This is selling for $480 the last time I checked, and it's crazy to think how cheap these batteries have become. One of the first batteries I reviewed on this channel was the 100 amp hour from SOK. And if my memory is correct, that was around $570 for that 100 amp hour battery. This is cheaper and it's more than 3 times the capacity. We've really come far in these past few years with this battery technology. As always, I'll drop some links down in the video description if you want to learn more. Please let me know what you guys think. Hit that like button before you go, and thanks for watching.